Now that Perseverance is on its way to Mars, what dangers will it face on its journey? Well, there are a few the planners had to consider. Today, we will focus on two of these issues, namely asteroids and micrometeoroids. The last thing we want to happen to our spacecraft is for it to have an unfortunate collision on its trip. So how do we prevent this from happening? Well, there is good news and bad news. From your elementary classes on the solar system, you remember that the asteroid belt is located between Mars and Jupiter, not Earth and Mars. The bad news is that many asteroids do not spend their entire trips around the Sun in this area. Allow me to show you the catalogued asteroids and their paths in the solar system. Now this is a worrisome image for what our interplanetary craft has to avoid, but don't panic, as one must realize, as Douglas Adams did, space is big, really big. You just won't believe how vastly, hugely, mind-boggling big it is. I mean, you may think it's a long way down the road to the chemist, but that's just peanuts to space. Listen, when you're thinking big, think bigger than the biggest thing ever, and then some. While looking down at the scale of the solar system, it may seem like there is a thick web of obstacles, but when you zoom onto the path our craft takes in space, even without planning for it, the odds of a collision are unlikely. If our spacecraft is the size of a pinhead floating in the ocean, what are the odds a ship will hit it? In addition, we plan out our courses with computer models to make these odds even lower. So, we are confident that Perseverance will not run into any mission-ending asteroids on its trip. Now we move on to micrometeoroids. Micrometeoroids are composed of asteroid and comet fragments as well as dust of miscellaneous solar and exosolar origins. This dust flies around the solar system at significant velocities that can punch holes in spacecraft if their hull is too thin. Whenever there is a meteor shower, you are seeing a patch of this dust burning up in the Earth's atmosphere. The distribution of these micrometeoroids increases with decreasing mass, and due to the velocities that these objects travel, they tend to vaporize on impact. This is actually good news for our robotic spacecraft. Even if it is impacted by a larger micrometeoroid punching through the thin shield, which, of course, is unlikely, the resulting plasma will quickly disperse and not deal significant damage to our craft. Anything larger is not anticipated due to the statistical insignificance for this trip. That about sums up this video on the asteroid avoidance and protection for your Earth-Mars trip. Just double check the asteroid catalog, put up your shields, and enjoy the ride.